So welcome to this presentation looking at worked example videos in undergraduate engineering. I'm Sarah, I'm a lecturer in learning and teaching at the Queensland University of Technology in Brisbane, Australia. And today's presentation is part of the AAEE Awards Roadshow for 2020, which I was invited to participate in after winning the citation for early career contribution to engineering education last year. So today I'm going to be talking about worked example videos, which is an approach I introduced into a range of engineering subjects over a number of years at QUT in order to move toward a blended learning model. So just to start off with a bit of an introduction to what a worked example actually is, it's basically an expert solution to a problem. So I've got an example on the right hand side here which is drawn from dynamics. So this is the problem. It's basically asking how quickly this rod is going to rotate as it moves toward the ground. And the worked example is basically this solution that sits underneath, which works through step by step how to develop the answer to that problem. So worked examples are a key learning tool in many maths heavy subjects, and their worth or benefit to learning and teaching is very much documented and evidenced in the literature. Basically, the really highly structured step-by-step approach reduces the load that's imposed on the learner's working memory, which means that they can have enhanced learning outcomes within shorter timeframes compared to other methods, such as discovery learning or just straight problem-solving practice. So in terms of how worked examples can be presented to a learner, there's a couple of different ways. So traditionally, they might be presented live, so live demonstration. So this would be, say, in a lecture or tutorial environment. You would have the teacher working through the problem, say, on the board, and potentially you'd have the students copying down those answers. So this has a bit of a challenge around accessibility, just because you need the learners to be in the room to be able to see the benefit of that demonstration. Another way that worked examples are traditionally provided is work solution documents, and that's representative of what I had on that previous slide where you just have the written solution. So while this has the accessibility, you can look at that document from anywhere at any time, it's poor at communicating the why behind the solution process. So what I mean by that is there's no real context given for, why are these arrows, what do they mean, why are they drawn in those particular directions, why were these particular equations chosen to be used. You've sort of lost that background thinking processes that hopefully, if done well, would have been communicated through that live demonstration. So what we can think about then is the third type, which is worked example videos, which tries to get the best of both worlds. So a video is going to be accessible, you can watch it at any time, any place, and a video can be narrated, so you're able to add in that reasoning of why the problem is being solved in a particular way. So I adopted this approach, the worked example video approach, in order to develop a series of videos demonstrating problems across engineering subjects. So I've got an example of what that looks like here. This one, when I play it, it's going to not have narration over the top, just for this particular example that I play today, and it's going to be sped up. But let me just show you what that can look like. So basically at the beginning of the video I read out the problem, then discuss the general approach I'm going to take. Then I work through step by step, so I'm able to explain why those arrows are being drawn a certain way, why we're applying these particular equations, why we're putting in things as a positive or a negative into the equation. I'm able to go through how we solve all those equations simultaneously and then get a final answer. So in this case it's 3.22 radians per second squared is the rate it's going to rotate at initially. So in terms of how I implemented this approach, I developed the videos as supplementary material for each of the different subjects. So what this looked like is for each weekly topic, I created videos. The first video in each case would be a recap. So this would introduce the equations and the background knowledge that's needed to then attempt the examples. And then I would create 3 to 4 worked example videos for each of those topics. So the videos were typically 10 to 15 minutes in length, although some were shorter, some were longer. They were produced on a Microsoft Surface Pro with the pen accessory, and I used Screencast-O-Matic in order to record the audio and visual delivery. I used a very conversational style in the videos, so that's similar to what you would have expected within like a tutorial environment, and there was very minimal editing. So basically whatever I recorded was what got uploaded. I uploaded each of the videos to YouTube, and I will note here that they were unlisted on YouTube initially, so this means that they could only be accessed via the Learning Management System, or LMS, because they couldn't be searched through the YouTube search mechanism. And the videos were introduced as supplementary follow-up activities. So initially I implemented the videos into the 3 engineering courses that I'm going to discuss in detail today. However, I have since implemented the videos into a business statistics course, and I've also developed videos as solutions to sample exam questions across a few other subjects, including one of the ones I'm going to talk about today. So in terms of the context, so again, I'm going to focus on these 3 engineering subjects. I have introduced it into mechanics, dynamics, and control systems. So they're at a range of levels. Mechanics is first year, dynamics is second year, control systems is taken typically in a 3rd or 4th year. And I've introduced it since 2016, which means quite a few cohorts have been captured through this process. In terms of the number of videos, dynamics and control systems are a very similar number. However, for mechanics, it's a little bit higher, firstly because mechanics is quite quick to do some of the questions because they're a bit simpler. As well, I introduced 20 videos as solutions to the sample exam in this particular subject. In terms of the number of views, you can see that there's quite a lot that have clocked up there, as well as the number of hours that have been watched. And I'm going to talk a little bit about results I got from surveying of students, so that's what's down here at the bottom. Alright, so jumping into some key findings from my implementation across those couple of years. So the first key finding is that usage of the videos is very strongly correlated with assessment. So I've got a graph here showing the week of semester and the number of views which are normalised to per 100 students. So what we can see is it kind of looks like students aren't particularly using it through the teaching weeks of semester, which is up to week 14. However, when exam block hits, there's a massive increase in usage. So exams preparation is very much a driver of usage. However, if we sort of zoom in on what's happening through these teaching weeks, which is what this inset actually is, we can see that there are peaks and troughs actually occurring. And if we consider the black line, which is control systems for a moment, what we can see is that this trough here, it actually corresponds to the first problem solving task being due. And the second peak here corresponds to the second problem solving task being due. And you can make similar conclusions about the other lines as well. So yeah, usage very, very much tied to assessment. So the next key finding was that about 90% of students were actively engaging with the videos. So by this, what I mean is that they were actually solving the problems that were presented independently. So that's what this graph here is presenting. We can see that less often students were attempting after or before watching a video. Most of the time students were attempting while watching, and this is very few that weren't attempting at all. So it's very much, I guess, an active process that students tend to engage in terms of, actually solving those problems rather than just sitting there passively watching. So this was also supported by comments that students made around how they use the videos. So students would often describe pausing the videos in order to work on the problem independently. And they would restart the video if they got stuck so that they could get a hint on what to do next, or as well to verify that a solution that they had developed was correct. Students would also talk about skipping and rewinding a video in order to target sections that they were interested in. So the next key finding that I had was around the impact on understanding and performance that students perceived. So this was measured through Likert scale responses. 1 was strongly disagree, 5 was strongly agree. So for the first one here, it's asking about understanding improvement, and we can see that very much students are sitting in those agree areas. And this one's asking about whether students think that will translate to getting a better grade. And again, it's very much on the agree side for that. And this is consistent with other studies which have looked at implementing similar video interventions, which have shown improvements in content understanding and grade performance. So the last key finding I have here is around course satisfaction. So at QUT we have a survey that runs at the end of every semester, like most universities, where students get to sort of rate how the semester went for them and what they thought of the teaching and unit experience. So there's a question that's asked which says, overall I am satisfied with this course, and it's a, again, Likert scale 1 to 5. And what I've got plotted here is how the response to that question has changed before videos versus after videos. So this survey is run twice at QUT, once around the midpoint and once at the end. But what we can see is that the grey lines here, which were before videos were introduced, so we see a big improvement in terms of the satisfaction after the videos were introduced for each of these cohorts. Same thing here, the grey is before, blue is after, so there is a jump. And for control systems, same again, although this one, it's worth noting, was already performing quite a bit better than the others, so it's a smaller jump overall after the videos were introduced. Alright, so that was sort of the first study that I looked at doing for these worked example videos, and I guess it basically showed that they were effective, they were being used. But I sort of had questions around why. Why were these videos, so effective and students were so keen to use them? So what I decided to look at was analysing the survey data that I had accumulated and looking at it through the lens of the technology acceptance model, which is a model that's able to explain why people choose to use a particular technology. So there's a range of external variables, which I'll come back to in a second, but these influence the two main cognitive beliefs of the technology acceptance model. So there's someone has perceptions around how easy a technology is to use, and they also will have perceptions around how useful that technology is. And in the case of education, this usefulness is usually how useful they think it is for their learning or to get a good grade. So these two perceptions feed into someone's attitude toward using a technology, their intention to use it, and then ultimately whether they choose to use the technology or not. So what I looked at was trying to figure out what are the external variables in the case of worked example videos that influence these perceived beliefs. So what I did is perform a thematic analysis of student responses to the survey in order to theme or identify the themes that really fed the perceived ease of use and perceived usefulness attributes. So this is what I came up with. I've got 7 kind of key areas, and I'll just quickly run through what each of them sort of mean. So the first one, accessibility, this influenced perceived ease of use. So accessibility, people talked about the fact that the videos were really easy to access because they didn't have to, say, be on campus. They could log in at any time, any place, and look at them. People also talked about the YouTube platform as being really easy to use and accessible, basically because often people had quite a bit of experience in using YouTube before engaging with the subject. There was also the personal agency fed perceived ease of use. So personal agency basically related to the control that students had over using the videos. So they could pause the video at a time that was convenient to them to be able to work on the solution, and then replay it, maybe when they got stuck or to verify their solution. So they were very much in control of how they engaged with that video. They could also skip content if they weren't interested in it, or rewatch content multiple times if they needed to. So yeah, there was very much that learner control in there. The next one was around findability. So in here, students talked about the fact that it was very easy to find what they were looking for within the worked example videos, simply because they were quite short. And they had, good names associated with them, which was different to the lecture recordings, which would often be 2 hours with no sort of signposting around what was being covered in various bits. So if a student was trying to look for a specific, clarification on a specific concept, it was quite difficult to find that within the 2-hour time span. So the next one was around instructional design and production. So here students talked about how the length met their expectations, so the videos weren't too long. Students also talked about how it was nice to have that really conversational style. They talked about it being quite personal and feeling like they had their own tutor working with them. And I think also interestingly, students didn't really criticize the low production quality associated with the videos. It was viewed quite well. So moving on then to the features that influenced the perceived usefulness. The first one, and definitely the most dominant, was the explanations associated with the videos that really drove understanding. So students talked a lot about how those videos and the explanation of why the process was being carried out in a certain way, addressing common misconceptions, also sometimes as well talking about alternative ways of approaching a problem. Those were really what fed those usefulness perceptions. The next one was around content scaffolding. So by this I mean that having the recap video followed by increasingly difficult worked examples were well received. Students felt that they were sort of bridged into being able to attempt those more difficult problems. And the last one there is around course alignment. So students really felt the videos were useful when they were connected really well to the overall unit, and in particular though the assessment. And this very much goes back to those trends that were observed around assessment driving usage of the videos. So the other part of this study is I looked at what recommendations I could make in order to further enhance this approach. So I've got a few of them here, which I'll just quickly highlight. So the first one is around the fact that YouTube was found to be really user-friendly and stable. Students really liked it. However, students also talked about wanting to use some of the extended capabilities. So it would be worthwhile exploring the use of playlists, subscriptions, and commenting in order to enhance the approach. The next finding I had was around lack of awareness could be a bit of a barrier to students accessing the videos. So this was most often talked about by students as not being aware of them until exam block rolled around. So given assessment is a really key motivator for usage, I think it would be worthwhile implementing a communication strategy where those work example videos were linked directly to assessment in order to drive that engagement earlier on in the semester. The next thing I had was students were really exercising their agency through choosing the content that they watched and using the video controls of pausing, rewinding, and so on. So what I would recommend is developing those worked example videos at a range of levels so that students who have varying levels of interest, background knowledge, and so on can be encouraged to engage. So videos could be targeted to those who lack foundational knowledge, as well as being able to extend students who are high achievers. The next one was around students naturally using active learning approaches when interacting with the videos, but those strategies that they used changed as they developed toward mastery. So what this meant is students look for different things from the videos at different points in their learning. At the beginning, they'd be more interested in watching more of the video. However, as they got more confident with the content, they'd be more likely to watch the beginning, attempt it themselves, and then just verify the answer at the end. So what could be considered is including alternative way of communicating the answers, such as just providing students with the final answers in order to accommodate those different strategies. Learning was improved through the narration that explicitly and thoroughly communicated why the solution was being carried out in a certain way. So students should definitely focus on providing that clear communication of solution processes, including potentially exploring alternative methods of solving a problem, even if the videos increase in length, because students have the ability to, again, target the parts that they're interested in. So yes, educators shouldn't be too worried if the videos become a bit longer. And the last one I've got there is around students valuing the worked example videos using the terminology and notation that they use in the face-to-face classes. So this is another aspect of that course alignment. So I think it's definitely worthwhile investing the time to make simple educator-made worked example video content as students perceived it as quality assured and personal. So that's all I have in terms of this presentation. There's a few links there in terms of my contact details, the YouTube channel, which has a range of the videos publicly available now if you're interested in having a deeper look. And also there's a link to my staff profile there where you can access the various journal articles that I've written up on this particular topic. So that's where I'm going to leave it in terms of today. Thank you for paying attention throughout that whole presentation, and feel free to get in touch if you do have any questions or want some further clarification on this particular topic. So thank you.